Okay, so isometries. Remember, we have three. We talked about this yesterday. We have the translation, which is a slide. Remember that with a translation, you go the same distance in the same direction along what we call a vector. Okay. On the rotation, it's a turn. We turn the same angle, like the same angle measure, in the same direction around the same point. Okay. And then the reflection was the last one. It's a flip. And it's important to remember that when you reflect, what happens is this point, when it's reflected over the line of reflection, is congruent from the line of symmetry. So this point to the line of symmetry and this point to the line of symmetry are the same distance. They are congruent distances, and they are also perpendicular. The line of symmetry is perpendicular to, if I drew a line from point to point, that would be a perpendicular line. Does that make sense, what I'm saying? Okay. So, the non-rigid transformations. The first one we've got is a dilation. Who goes to the eye doctor? Raise your hand, go to the eye doctor. Do they dilate your eyes? Yeah, sometimes they take pictures now. But if they dilate your eyes, what happens? Do you guys know what that means? Yeah, it makes it big where you can't see, right? Like they enlarge your pupils so they can like look in your eye to make sure that your eye is healthy. Okay, so a dilation, I always think of the eye doctor because it's not fun getting your eyes dilated when you can't see. But a dilation is either when you go from your original size to bigger, an enlargement, or from your original size to smaller, which is a reduction. Okay. The thing that we need to write here is that since our shapes change size, they are no longer congruent. What they are called is similar. Okay, so they are called similar. So let's go ahead and circle enlarges or reduces. Okay. And again, when we go from pre-image to image and we get bigger, or we go from pre-image to image and get smaller, the size changes, but a dilation does preserve angle measurements. Okay, so preserves angle measure, but not lengths. And this is called similarity. So it produces writing is hard. Similar, which is like a little tilde. Remember that congruent is the equal sign with the little tilde over the top. Similar is just a little tilde, no equal sign. So it produces similar figures. So that is the sign for the word similar. And we will have a whole unit on similarity. The last non-rigid transformations are what we call compressions, stretches, and compressions. Okay, vertical stretch would mean making it longer vertically. Okay, a compression is we are scrunching it vertically. Okay, a horizontal stretch where we're making it wider this way. A compression would be we are scrunching it in horizontally. Does that make sense? So when that occurs, we do not have congruent figures. Our figure changes size and shape. Okay, so it's no longer congruent and they are no longer similar. They're neither. Okay, it's still a transformation though. So not congruent, not similar. Questions so far? Okay, when you're ready, flip. Okay, all right. So we are going to go through these and state what type of transformation has occurred, and then we'll tell whether it's an isometry or not. So if we look at this first one, if we're going from the figure on the left to the figure on the right, what did we do? What happened there? What's this motion? Yeah, rotation. So this would be a rotation. Is that an isometry? Yes. Okay, so the next one, if we go from the figure on the left to the figure on the right, or vice versa, What's that motion? What's happening there? It's the slide, which is in geometry called translation. I heard it, translation. Is that an isometry? Yes. Okay. This one, we are going from this figure from on the left to this figure on the right. What happened there? A dilation. Good. It got smaller, but it's still the same shape, right? Just a smaller version. So this is a dilation. Is that an isometry? No. Good. Nope. Okay. Figure on the left to the figure on the right. Well, yes, reflection. There is an imaginary line going through the center there, and it is reflected over that line. So this is a reflection. And is that an isometry? Yes. Okay. I want you to determine what these next four pair are. Okay. This one, I'll just put arrows. This goes to this. We'll say that this is going that direction. I'll let you take care of that one, and this one is going to this, just to kind of give you a heads up. We can go this to this. It doesn't matter. This one doesn't really matter which one you go to. Yes, bigger or smaller, so if you need to look back, you can on the page before. When your pencil is down, I know you're ready. I'm going to pause this real fast. Back on. All right, hopefully you and your partner agreed. So let's start with this one down here. Okay, if it is moving in this direction, what's that called? Rotation. Is that an isometry? Yes. Yes. Let's go to this one. Yes, this is a reflection. There is a line of reflection right here. Okay. And is that an isometry? Yes. Yes. And if we're going to from small to big? Good. Dilation. Is that an isometry? Nope. Okay, last one. I saved this one for the last. Okay. From this shape to a whole different shape. Ooh, close.
Vertical compression.
It is a vertical smash, which is a compression. Okay, vertical compression. So is that an isometry? Nope. I feel like the Hulk there. All right. Questions on those? Okay. Next example, we are going to select the diagram where a quadrilateral ABCD has been reflected in line N. Notice on these, the top has no little apostrophes, no primes. What would we call the top? Pre-image, and the one below the line would be the image, okay? So because we have the little tick marks, they're very tiny, but they are there. So when we are looking for a reflection, what we're looking for is that each point is the same distance on the pre-image to the line of symmetry or the line of reflection as its image point. And that line, if I were to connect the pre-image point and the image point, they would be what to the line of reflection? We make these type of angles. What would that be? Perpendicular. Okay, be perpendicular. So I just pick a point to start with. Okay, if I'm going from B to B prime, does that look like the same distance from the point to the line of reflection? No. Does it look like it's a perpendicular line? No. Can this be a reflection then? No, so it's not that one. Okay, so B to B prime again, I just start with one. You could go C to C prime. I think it's better to kind of look at this one that's a little bit further from the line. So B to B prime, if I were to connect those, I'm going to use a straight edge. If I were to connect those, do they look the same distance from the line of reflection? Yeah, okay, check one. But then, does this look like a perpendicular line to the line of reflection? No. So can it be a reflection? No, it has to be both of those things. So it's not that one. All right. B to B prime here. Do those look about the same distance? Yes. Okay, does this look perpendicular? Okay, we got to try another one then to make sure. Let's go C to C prime. Do those look the same distance? No. So can it be a reflection if one point does and one point doesn't? No. So it's not this one. In fact, this one is going to be a what? A slide, a translation. Okay, so it's not that one. Hopefully it's this one. Otherwise we don't have an answer, right? Okay, B to B prime. Do they look equidistant to the line of symmetry? Does it look perpendicular? Okay, let's do C to C prime. Equidistant, hold on. Equidistant to the line of symmetry? Perpendicular? Yes. Okay, D to D prime. Equidistant? Perpendicular? Yes. Okay, A to A prime. This is not a great pencil. Equidistant. Perpendicular. Okay, so this would be a reflection, yes? Yeah. Does that make sense? How do we check it? Okay, this is our answer. Whoop. Yes?
How would we check it? We do like transformation or translation or
Like a composition?
no, like if the question was asking like select the diagram or
Oh, if it was a translation instead?
yeah, translation
So-
or reflection.
So translation, we would check if all the points are going in the same direction, the same distance. That's how we would check that. Okay. A rotation, we would see that all the points are turning the same degree in the same direction. So it'd be like a turn. Okay. All right. Good question. We ready to go on to example 8? Okay. Example 8. So it says, find the value of each variable given that the transformation shown is an isometry. So what does it mean? If it's an isometry, they're the same, okay? They're the same. So what we have to do, we need to look at this transformation statement. The little arrow means Hij has been transformed to LMNO. So we've gone from this one to this one. This would be our pre-image. This would be our image. Does that make sense? So this is the pre-image. This is the image because of this transformation statement. This also tells us which angle goes with which, or which vertex goes with which. So H corresponds to L. So H corresponds to L. I corresponds to M because they're in the same position. So I to M. J goes with N, so J to N, and K goes with O. Okay, it will also tell you your segments that go together. So HI goes with LM. HI goes with LM. Does that make sense? What type of transformation happened here? Yeah, this was a rotation. It got rotated, right? So this is a rotation. We want to pair up the corresponding sides. So we want to know what goes with JK. Okay, so I'm going to erase this so I can highlight over here since I didn't bring my highlighters up here. Okay, so JK goes with NO. Do you see that? So NO is here. So JK goes with NO, and since they are congruent figures, those sides are congruent. So how do we set it up?
3x equals 18.
Yeah, 3x equals 18. Okay, so x will equal 6. Okay, now we need angle I, right? Angle I is right here. So what in our statement, what does I go with? Corresponds with angle
M.
M.
So right angle making it 90 degrees.
Good. These two correspond. So right angle, 90 degrees. So if they correspond and they are congruent figures, how do we set this up?
15y equals 90.
Good. 15y equals 90. So y equals,
6.
yeah. What questions do you have? Yes, cool.
Aren't you not supposed to make two different variables the same number?
No, if they're different variables, they are different, usually different numbers.
Well, in this one, they're both 6.
That's okay. They can be.
I thought they weren't.
They just happen to be.
Okay.
They don't always, not always are, but they can be. Does that make sense?
Yeah.
Okay. Okay. Next one. Again, look at your transformation statement. We're going from A, B, C to D, E, F. We know they are isometries, so they are congruent figures. Okay. So if we want to find X, we need BC. What side goes with BC?
EF,
Yeah, EF. Okay, so what is EF equal to?
20.
So since they are congruent, we know they are congruent sides, so we can set them equal to each other, right? So 2x plus 4 equals 20. We will solve for x. So subtract the 4. Yeah, divide by 2. X equals 8. Okay. We also need y here. So y is with angle E. What goes with angle E?
B.
Yeah. Okay. Again, if they're congruent, they are equal. So 5y equals 30. So what does y equal?
6.
There you go. Okay. Questions? Now, this one. Oh, this was a rotation, right? Rotation. What was this one?
Slide.
Which is called a translation. And this one we see a line, so what will this one be? Yeah, this will be a reflection. Now, we don't have a transformation statement here. We're going to make one, okay? Remember, if it's a reflection, our points should be equidistant from the line of reflection, and they should create perpendicular lines with the line of reflection, right? Okay, so if I'm going from C, C goes with which part of this shape?
Q.
Q, yeah, C goes to Q. Okay, B goes to N, A goes to O, and D goes to, yeah, ooh, I was totally off there, P. Okay, so I'm going to, you don't have to go in alphabetical order, but you do need to go consistently around, like, so choose a letter and go around to name it. So I'm going to call this A, B, C, D. So I'm going to say A, B, C, D is transformed to, again, A goes with O, B goes with N. Oops, I put B, N, I meant N. Okay, C goes with Q, and D goes with P. So I need to put them in the correct order with what they correspond with, what angle they correspond with on the other shape. Okay, and this is going to help me find the missing pieces. All right, let's start with, we can start with X. Okay, so X is at N. What goes with N? B. And what do we know about B? Yeah, it's congruent to D. So this is also 95, right? So how would we set this one up?
3x plus 35 equals 95.
Okay. I'm not going to solve it. I'm going to go and set up the next one. Is that okay? All right, so we've got X, Y. Y is at C. What goes with C? Ooh, Q. We got a conundrum here. Okay, here's the deal. Let's look at A. A goes with what?
O.
Okay, so if O is 110, A is also,
110.
okay, does anybody know what the angles in a quadrilateral add up to be? 360, because you can cut it into two triangles, and triangles are 180, right? So this whole thing should equal 360. So in order to help us, we need to add up and see what we have and subtract from 360 to see what we need. Does that make sense, what I'm saying? Okay, so let's add 110, 95, and 95. So 110, 95, 95. Who's got it for me?
320.
Is that right? Everybody agree? Is that 320?
Add 95 and 95 together. Isn't it 300? I see what I did wrong.
What is it? 300.
I see what I did wrong.
That's okay. So 300, the whole thing is 360, so let's subtract. So what should 2y be equal to? 60. This should be 60, right? So 2y should be equal to 60. So we'll say 2y equals 60. If you don't remember, the interior, I'm going to just put a little note. Interior angles of a quad equal 360 degrees for further reference. Okay, so we got x, we got y, z. Z goes with AB. So what goes with AB? ON. Okay, AB goes with ON. So we have a half Z equal to 10. Okay, what's the last one? Oh, W. Okay, W is here. W goes with QN, right? QN is right here. What goes with QN? CB. Good, CB, which is right here. So that would be 2/5 W equals 20. Do you remember how to solve these with the fraction? Okay, this is just saying I'm multiplying z by 1 and dividing by 2. So I'm going to do the opposite. Instead of divide by 2, I'm going to times 2. So that gives me 1z equals 20. And that 1 really doesn't matter. I would divide by the 1, but does it matter? Nope. So it's just z equals 20. So what would I do here? Instead of divide by 5, I multiply by 5. So that gives me 2w equals 100. And then how do I get rid of the 2? Divide by 2, so w is, does that make sense? Okay. All right, I think that's it. Is that all she wrote? That's all she wrote. What do we think? What questions do we have? Do you understand how to set up a transformation statement and how to read it? Okay, these are important because it tells you what parts of the pre-image go with what parts of the image. Okay, so use it to your advantage. All right, I'm going to pass out the practice, but then we are going to go through the test. Okay? All right, here we go.